Hi, I'm Gary Stafford, a Principal Solutions Architect here at AWS. This is a brief demonstration of the video search agent powered by TwelveLabs on Amazon Bedrock, OpenSearch, and Strands agents, a framework for building agents also created by AWS. This brief demonstration is part of a longer video that I'll be coming out with soon. On the screen, we have a Gradio UI for the video search agent powered by TwelveLabs. In the upper left, we have the user input. This is conversational, so we are interacting with a single agent on the back end built with Strands agents. The user input is on the upper left. We have the search button, which will send the request to the agent. We have the ability to reset or create a new conversation. On the right-hand side on the top, we have the agent response. And then in the bottom, we have live system logs. So we can see all the standard out and standard error, and we can see all the thinking that the agent is doing, specifically the model which is powering the agent. Anthropic Claude 3.7, also running on Amazon Bedrock. We've given the agent access to a number of tools, some built-in tools through Strands agents, such as Calculator, Current Date, and Shell. We've also given it access to tools which I've created and are detailed in a longer video. Things like the ability to create a dense vector embedding from a text input, which will be passing into OpenSearch for a semantic query. Tools which allow it to do a semantic search for videos. Other tools which allow it to do a semantic search for video segments. And yet a final tool which allows it to perform a simple keyword search as opposed to a semantic search. So let me demonstrate how this works. In the README file for this project, I have some example prompts. Let me grab the first prompt and then I'll explain it after I paste it in. For our first prompt, which we've pasted into the user input window, find commercials that feature soft drinks and provide a ranked list of the top 10 results based on their score. For each commercial, include the title, a summary, the specific products or products featured, the score as a percentage, and the duration of the commercials. Do not include products such as alcoholic beverages or energy drinks. So we'll go ahead and hit search. While that's running, let me explain what should happen. So the Strands agent, which is backed by Anthropic Claude Sonnet 3.7, has a number of tools available to it. The agent should decide through reasoning which tools it needs to use to solve this particular query and in which order it needs to use those tools. So hopefully what it's going to do is create a dense vector embedding of the query. It's going to then use that dense vector embedding which it created using the Marengo model on Amazon Bedrock. It will pass that to OpenSearch. OpenSearch will perform a semantic search for those videos, and then we'll get a list back, and the model through the agent, the Anthropic Claude model, will be able to arrange results in the order in which I asked for it. So we see that we got 10 results back, which is what we asked for. And if we take a look, it looks good. Top 10 software drinks. We see a Pepsi commercial, Coca-Cola, another Coca-Cola, a Poppy, and then we see IHOP, sandwiches. We got the title, we got our score as a percentage, so that was properly converted, and we got our duration. The agent was able to take our input, our query, it was able to understand what it needed to do to solve the problem, and it was able to return the results we wanted. If we look down here in the logs, we can actually see what it did. We can see that the tools used in order to solve this particular query were create text embeddings and semantic search for videos. Those are the two tools I would have expected. Now again, this is a very simple example. Those are custom tools, but it only used two tools, which again is fairly simple for an agent. We could expect it to use a number of tools if necessary. So 2 isn't terribly complex, but it did use the correct tools in the right order without any prompting or instruction. If we scroll up a little bit, we can actually see what it did. So here we see the use of tool number 1, so create text embedding. It said, I'll search for commercials for soft drinks and provide a rank list based on score. Let me do that for you. First, I'll create text embedding for your search query, and then I'll perform a semantic search for the soft drinks. Exactly what I would expect it to do. Now, I didn't give it any explicit direction. I gave it the tools necessary to do this, but it chose which tools to use in which order and how to use them. Then it generated a text embedding using Amazon Bedrock for commercials featuring soft drinks, soda, cola, carbonated beverages, or non-alcoholic beverages. I didn't use those exact words. That's a very good query to use to search OpenSearch for the right commercials, but it decided based on my query what it was going to use as that dense vector embedding. Again, this is the power of large language models, of reasoning models, of models that can use tools, and of agents like Strands agents framework to build agents. It was able to derive from my query what it needed to do, was able to create a text query, and then convert that to an embedding. So we see that down here, created that embedding, and we just output a snippet of it here. And then it was able to use that to perform a semantic search. Now I'll use the embedding to search for the video. So we can see here it called tool number 2, semantic search for videos. So out of the 3 or 4 possible tools it could have used that are associated with searching in OpenSearch, it used the correct one. That's good. It called the endpoint and it got several results back, and we can see those results here. So it got all 10 results back and it formatted them properly. There's no specific tool for formatting. I returned all of the fields available except for the dense vector embeddings, which we don't need and can take a lot of room. But it decided based on the fields that I asked it for, which fields to extract, what order to put them in, how to format them. We got a bulleted list back, we got markdown back, and provide that back to me in the fashion that it did. So that was all the large language model behind the agent that had that knowledge on how to do that. So that's a simple example of using an agent. Now I'm going to ask a follow-up question. Let me grab this question, and then while it's processing, we'll take a look at it. So exclude any results where the main products being advertised are not software drinks. At the end of your response, list any omitted titles along with a brief explanation for their exclusion. So it's already done the search. It's already found all of the products. But now I'm saying, hey, some of these don't appear to be soft drink product manufacturers commercials. So Pepsi looks good. Coca-Cola looks good. Another Coca-Cola. Poppi is a newer brand of soda or soft drink. So that looks good. But then I see things like IHOP. I see the Tootsie Rolls commercial. I see maybe a Taco Bell commercial or Doritos commercial. So those aren't really featuring soft drink products specifically. So I'd like to get rid of those. So let's ask this follow-up question or query, and we'll see how the agent handles that with its tools that it has available and the knowledge it has through the large language model. So we see that we got some results back from that follow-up question. So let's take a look at the final list. And we can see here, based on the search results, I've compiled a ranked list of commercials that specifically feature software drinks as the main product. So again, it's refined the question a little bit based on my follow-up. And we have a ranked list back here. So we have Pepsi, Coca-Cola, and Poppi. That looks right. So it kept the first 4, which obviously had the highest score since they featured soft drink products. And then it omitted the other 6, and it told us why it omitted it. What it did is it actually started, I won't say started over again, but it used the same tools again in a different way. So it used the create text embedding, and from that original question plus the follow-up, it changed the dense vector embedding that it created. And that was based on this query: Pepsi commercial, Coca-Cola commercial, soft drink advertisement, soda commercial. So it decided that maybe that was a better way to identify the specific commercials which featured a soft drink. We can also see here that it tried the keyword search. So performing a keyword search for Sprite, Mountain Dew, Dr. Pepper, 7-Up, Fanta, or soft drinks. You can kind of see its logic. Is this the best way to solve this problem? It made a few calls, maybe it made a few extra calls, it tried a few different things. That's based on the agent, the tools that you provided, the description of the tools you provide, and the model which is behind the agent, the model which provides the agent with reasoning capability and tool use capability. Potentially changing the temperature, changing my question, changing the model, certainly changing the tools available to the agent, or changing the descriptions which are provided as part of the tools. This problem may have been solved in a more succinct fashion. If I were to run this again, odds are that would have solved this slightly differently. Because the temperature isn't 0, it may have used a different text embedding the first time. It may or may not have tried the keyword search. So what really counts is the final result correct? And I would say in this case, based on my knowledge of that library, that index of commercials, these are the 4 commercials which specifically contain a soft drink product as the main product being featured or sold in the commercial. So I would call this a success, and then we can kind of look down here at the logic. Very brief demonstration, really demonstrates the power of Strands agents, TwelveLabs on Amazon Bedrock, Marengo, and Pegasus models, and then OpenSearch for the index. So combining all of that together and then using Gradio as the UI simply to host the conversation with the agent.